Hi, welcome to Dissolve Chemistry. Dear students, in the previous video of thermodynamics, we have discussed regarding intensive and extensive property. What do you mean by intensive property? The property which is independent of the quantity of the matter present in the system, whereas extensive property is that property which depends upon the quantity of the matter. Now we will continue our discussion on this with the next topic, that is state variables. State variables. Well, prior to going for its definition, let me give an analogous example. Well, you assume that you are watching a cricket match on the TV screen, where there is no scoreboard is shown on the screen. So when the scoreboard is not shown on the screen, so then what you will presume that at what situation the match is going on, you cannot identify. Means the way the match is progressing will be came to know only when the score is displayed on the screen. It means the condition or the state of the match is described by the scoreboard. Similarly, when you take a thermodynamic system, so then that system has to be described or defined by some terms, and those terms which are going to tell you the state of the system, at what state it is existing. So therefore, the variables are the properties which are going to tell the or define the state of the system are said to be state variables. Or we can define that if I vary these properties, when your system is also going to vary. So that means the properties upon varying its value, then the state of the system is also going to change. For example, you take temperature, pressure, volume. Well, suppose if I vary the temperature, say for example it is at 25 degrees Celsius. Now if I rise the temperature by 60 degrees Celsius, say for example there is a gas, right, 25 to 60 degrees Celsius I took. So then what happens? The state of the system will vary, means pressure will vary if you are carrying out at constant volume, or if it is fixed with a piston, then what it will do. So there will be an expansion we are going to see. So like that, all the means total state of the system is going to vary. So such variables upon varying, if the state of the system is varying, then we call it as what? State variables, or the terms or the properties which define what is the present state of the system are also referred as state variables. Means we can define in two ways. Well, I hope that you have understood what do you mean by state variables. Now, next we move on to the next topic, that is state function and path function. Okay, prior to going for defining these terms, we will take two analogous examples to understand this concept. Well, first one is that take three containers, fine, containing same amount of water, three container let us take, and what is our experiment is that I want to change its temperature from 25 degrees Celsius to 60 degrees Celsius of all the systems. Okay, so all these containers containing water I took, and our aim is to raise their temperature from 25 to 60 degrees Celsius. That's what we want to do. So that can be brought by, or we are going to bring that by three ways. One is, let us directly keep it on a open flame, okay, such as burner you can take. Okay, on the burner we will heat, and in another container we will immerse an electric heating coil. Okay, and in the third one what we will do, we will take, okay, a stirrer, right? We will take a stirrer, and right, by stirring water or by churning the water, we want to raise its temperature. Means these are the three different ways we are going to, or we are adopting to raise the temperature from 25 to 60 degrees Celsius. Now let me know that after doing that work, means after achieving this 60 degrees Celsius, okay, of all the whatever the containers we have, all have been achieved 60 degrees Celsius. Assume that. Now let me know. So the temperature. So initially it was 25 degrees Celsius in all the containers. Now it has reached to 60 degrees Celsius. So therefore, either you have heated the water on the open flame, or by immersing an electric heater, or by churning with an stirrer. So irrespective of that, the temperature goes to 60 degrees Celsius. It won't depends upon the way you have brought this change. It only depends upon what? The initial what it was, now finally what it was, irrespective of the way you have brought. Another aspect we will see that, so here in heating, and by heating by immersing a heater and keeping it on open flame and churning with the stirrer. So where do you find the maximum work has to be done by the system is here we have to do maximum work on the system. So why? Because churning means again we need lot of time as well as work has to be done much here compared to a heating with electrical coil or on the burner. Meaning is what? Work depends upon the way it has been brought, means on the path of the, okay, depends upon the path. So therefore we call it as what? Work is path function. Okay. Similarly, temperature. Initially we had 25 degrees Celsius, 60 degrees Celsius in all the containers. Meaning irrespective the way you have brought, its temperature has gone to 60 degrees Celsius. So therefore your temperature is called as state function. Okay, I think you have understood what you mean by state function and path function. Let us define the terms. The thermodynamic function which only depends upon the initial and final state of the system, but not on the way that system has been changed, then it is called as state function. Okay, so therefore state functions, you can take example your pressure, volume, temperature, okay, so then internal energy, then you can take enthalpy, okay, entropy. All these properties are called as state functions. Entropy, fine. Similarly, we define what is path function. So the property whose value depends upon the property which depends upon the way change is brought in the system. Okay, then it is called as path function. Okay, it is called path function. Your example is work. See, already we have seen three ways of heating the water contained in different containers by three different means, and we observe that maximum work is done when you go for mechanical stirring of water using stirrer, and compared to that the work done here will be little less, and here will be it is little greater than this. Okay, so that is how the work is going to depend upon the way it has been brought. Fine. So this is how we are going to define what is state function and path function. I hope you have understood what the meaning of both the terms. Thank you.